So let's just go back and start talking about the factoring because that's going to be a really important part and probably one of the most important things that you learn in 1010 because you're going to be using it all the time in 1050. And for most of you, that's the next math class you'll be taking. So let's look at this 44 part A. And so remember that when our leading coefficient is not 1, right, we can't just, write down our parentheses and go from there. We actually have to multiply the first and last term together, right? So we're thinking to ourselves, what multiplies to be negative 12, right, the 2 times negative 6, and adds to be a positive 1. Because remember, there's a invisible 1 there, right? So, and so I know that 4 times 3 is 12. And if I want to add to be a positive 1, then 4 would need to be positive and 3 would need to be negative, right? And so then from there, you can either write down the 4-term polynomial and do your factor by grouping, or you could do the box method. I'll put the box method here, and then, let's see. Make sure I have enough room to write things in here, but you can do it whichever way you want, okay? So the 2x squared goes in the first box, then we're going to have a 4x and a negative 3x, right? Because we rewrote that 1x. It's going to be a 4x and a negative 3x, right? So we'll have 4x and negative 3x, and then we have negative 6, right? And so now we're just trying to factor out the greatest common factor in each column and in each row, right? So if we start with the top row, 2x can come out. Right, that's our greatest common factor there. And in the bottom, notice that both of them are negative. So we're going to pull that negative out. And then there's also a 3 in common. So the negative 3 is going to come out here. Then in our first column, we've got an x that's in common with both of those. And then on our second column, looks like 2 can come out of both of those, right? So then when we write down our answer for that, and I'll just put it in green here, so x plus 2 in one parenthesis, and then 2x minus 3 in the other parenthesis, okay? And how would you go about checking that that's the correct answer? Anybody tell me? How could we check that?
Is it the FOIL method?
Yeah, so you just want to FOIL those back out to see if you came out with, what you started with. And when you do that, you find out that you do. So that would be our answer. Okay, and I noticed on the quiz where some of the things said factor and other ones said solve. And so some people were getting those confused. And so make sure that if it says factor, you're just factoring them, right? You don't need to set it equal to 0 and solve anything. That's what we're going to do here on number 45. So watch what the question is asking on the test. Is it asking you to factor it or to solve it? Okay. All right, so let's try, let's see. Let's look at part C really quick. I just want to point out to you that sometimes you're going to have to pull out a greatest common factor before you can do anything. And so in this one, I see that 2 can divide in to 50 and also to negative 18. So if I pull that 2 out, then I'm left with 25x squared minus 9. And then you should notice that 25 is a perfect square and 9 is a perfect square. And so we're going to be doing the difference of squares on that. So 2 still stays on the outside. All right, and then I'm going to go ahead and just write down my parentheses here, because remember we said with the difference of squares, right, we'd be basically taking the square root of both of those numbers inside there to figure out what our answers are. So meaning if I did the square root of 25x squared, right, that's 5x. So I'm going to put a 5x here and a 5x here. Because if I multiply 5x by 5x, I get that 25x squared. All right, and then do the same thing on the 9. So if I square root the 9, that's 3. All right, so I get a 3 here and a 3 here. And then one of them has to be plus and one of them has to be minus, because that's what makes the middle term go away. Notice there's no x term in this, and there's never is an x term with those difference of squares. Okay. So if that's looking a little bit, you know, if you're like, oh, I'm not quite sure on that, make sure you look at some of that special factoring that we talked about before and really look at those again. Okay. All right, let's look down maybe a little bit more. Let's go ahead and do part B on number 45. All right, so on this one, notice that first of all, this is not in standard form. And so it's telling you to solve by factoring, right? But in order to do that, we've got to get it in standard form first, which means we need to get everything over to one side so the other side is equal to 0. So that means I want to subtract my 8x over here, and I want to subtract my 1 to the other side also. Kind of a mess there. Let's see. I'll rewrite it. So I've got the whole numbers underneath each other. All right. So when I combine our like terms together, right, remember x squared and x are not like terms. So we've got to write those down separately. So 4x squared minus 8x, but then I can do the 5 minus the 1, which is 4. All right, and now there's nothing left on that side, so it's equal to 0, which is what we were trying to do, get that equal to 0. And now I'm going to try and factor it here. Again, notice that there's a greatest common factor that can be taken out, so you want to make sure you do that first. What would our greatest common factor be?
2.
There's something a little bit bigger than 2 that can come out. 2 is a common factor, but can you see something bigger?
4.
Yeah, so let's have 4. Let's divide 4 out of everything. That will leave us x squared. Whoops, I forgot my x there. Sorry about that. So x squared minus 2x plus 2, or sorry, plus 1. All right, dividing a 4 out of everything there equals 0. And now I need to look to factor this other part. All right, my leading coefficient's 1, so I can go straight to my parentheses. And I'm thinking what times what is x squared, and that's x times x. And then what times what is 1 that adds to be a negative 2. And that would be a negative 1 and a negative 1. All right, negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. All right, so now I have these, right, parts for my answer, so I'm going to set each of those parts equal to 0. Well, remember when I set 4 equal to 0, right, so I'm just going to draw a little arrow that we're coming up here. When I set 4 equal to 0, that doesn't make any sense. There's no x to solve for there, and that's what we're trying to do here, right? We're trying to solve for x. So we're just going to forget about that 4. If there was an x on the outside, then yes, we'd need to solve for it there. All right, but then notice that the other parts are just the same, right? I've got an x minus 1, so let's set x minus 1 equal to 0. And so to solve for x, I just need to add the 1 over, so x equals 1. All right, and if I did that with the other parenthesis, I'm going to get the same answer. I get a repeated solution, but I only need to write that solution down once. So my answer on this is x equals 1. And again, whenever you're solving, you can always check it by substituting that answer back in place of x and see if you get a true statement, right? If one side of the equation equals the other. Okay, and that will work on there. Okay, you guys remembering this so far?
Yeah.
Okay. All right, let's look at some of this stuff on Module 8. The only thing that we really talked about in Module 8 was kind of determining how we can tell when there's, you know, a table like this, or if we have some data points, if something is linear, exponential, or quadratic. And so that's what we're trying to do on this, is see, you know, which one is which on this. Okay, so let's start with let's just start with this first one here. We're trying to figure out, right, if I'm moving from here to here, and here to here, and here to here, right, what am I doing, right? What it looks like, since it's going down, right, I'm either subtracting something or I'm dividing something. And to figure that something out, right, you can just kind of put in your calculator the 640 divided by 2560. And when you do that, you get 0.25. So that's 1/4. So it's either, you know, meaning that you're timesing by a fourth, or timesing by a fourth is the same thing as dividing by 4. All right, and so you kind of have to think about those the same way. I'm just going to write over here, or you can think about it as divide by 4. Okay, but when we're talking about things that are being multiplied, right, and if I do this again, if I take my 640 and times it by 1/4, I'll see, oh yeah, I get 160. If I take 160 and times it by 1/4, I again get 40, right, and so on. So timesing by 1/4 is what's happening there. So does that mean it's linear, exponential, or quadratic? Which one would that be? When we're multiplying, and it's a constant ratio here.
I don't know if it will be linear. Would it be linear?
So linear, so it's not linear. What are we doing when it's linear? Well, let's come back to this then, okay? We're not going to answer the question quite yet. Let's look at, you know, maybe some other ones here and maybe see if we can figure out, you know, which one's which. Okay, so let's do the one right underneath it. So on this one, right, I'm trying to figure out what's happening here. Right? Well, it's not moving by a big amount. Like this one looked like, I mean, I could tell I'd be, you know, multiplying or dividing, because look how fast those numbers are moving. Where these are more close together. So it seems like I'm probably going to be adding or subtracting. So again, like to figure that out, right, you're going to put 48 or negative 48, right? And then let's minus that negative 37, right? So negative 48 minus the negative 37 gives me a negative 11. So that's saying so I'm like subtracting 11, right? Negative 37 minus 11 gives me that negative 48. Negative 48 minus 11 gives me negative 59. Negative 59 minus 11 will give me negative 70. Okay. All right, so one of these, right, we've got multiplying by the same number. Here, we've got subtracting by the same number. Okay. Let's look at this other one here, the second one over. So let's figure out what our pattern is here. Right? And again, they're not going up by huge amounts, but it is going up, so I'm thinking, oh, I must be adding a certain number each time, right? So 10 plus what gives me 22? What am I adding there to get to my next number? Anybody?
Oh, sorry, what's the question?
What number am I adding? 10 plus what gives me 22?
12.
Yeah. Right, so I'm going to be adding 12 there. Now I'm looking at 22 plus what gives me 36. Well, it's not going to be 12 this time, but it's going to be 14
this time. Yeah.
Okay, and then what about the next one? 36 plus what gives me 52?
16, but I don't know. Hold on.
Yeah, that's right.
Oh,
16.
okay.
Yep.
So
and
then it's exponential, right?
So it's not exponential. So let's look at what's happening here, right? So these aren't the same numbers that it's increasing by each time. But if I do my second difference, right, and if that's a constant, if this one's constant, then that's going to tell us it's a certain type, right? So 12 plus what gives me 14?
2.
And then 14 plus what gives me 16?
2.
2. So I get the same thing here, right? So this has a common, so the second difference is constant. So let me write that here. So second difference is constant. On this first one here, we had a common ratio, right? And then on this one, right, we had a constant rate of change. Okay, and so those are the different things that we've talked about. Now you need to decide, what does that mean? Which one of these is linear? So which one do you think is linear? Let's see, I guess I don't have the chat up, so if some of you are putting things in the chat, okay, pull it over here so I can see it. Okay, so which one of these is linear?
Would it be the constant rate of change one?
Yeah, exactly. Constant rate of change. Remember, that slope has to be the same every time. And that's what this negative 11 represents, is our slope. So when you have a constant rate of change, that's going to be linear. Okay. All right, so what about which one would be exponential? The common ratio or the second difference is constant. Okay, Rebecca says the first one, and that's correct. When you have a common ratio, we also kind of talked about it as a constant percent, right? That's going to be exponential. And that means that we have
quadratic.
Yeah, so remember when we have that second difference is constant, that's going to be quadratic. Okay, so make sure you review over those and remember, how you tell by looking at, you know, like tables of values, whether they be linear, exponential, or quadratic. Okay, and you can practice on these other three as well later, you know, just so you can see if you can figure it out on your own. And then remember, the answers are also on the front page of our, well, I guess it's in your module 9 and 10, right? So there's the solutions to these also. Okay, so let's look at some stuff in chapter 9 then, this section 9.1. We talked about the square root function. And remember, to graph, right, a square root function, we're just putting numbers in for x, but we want to choose numbers that are perfect squares because that's going to make our y's whole number answers. All right, so meaning if I put, well, 0 is a perfect square, because if I did the square root of 0, right, put 0 in place there, I just get 0 for my answer. All right, so 0, 0 is one of my points. All right, what if I put 1 in place of x? Well, the square root of 1 is 1. So over 1 and up 1. All right, then 2 wouldn't be a good one to put in because that's not a perfect square. 3 wouldn't be a good one to put in because it's not a perfect square. But 4 would be a good one because the square root of 4 is 2. All right, so over 4, up 2. And then the next one, right, our next perfect square is going to be 9. The square root of 9 is 3. So over 9, up 3 would be about here. All right, so it starts there at 0, 0. It touches there, right, and goes over, you know, kind of up and over that way, right? But it's not going to go below, right? We can't have any negative numbers. So I want to make sure that's clear, right? I couldn't say -1 for x because when I try and take the square root of -1, right, that gives me an imaginary number. That gives me I, which I can't graph on this grid here, right? Because this is for real numbers. And so, so you can't put any negative numbers in, right? So our domain on this, right, would be from 0 to infinity. Remember, domain, you're looking at it from left to right. Right, so I'm going to say it includes 0, right, because it's right there at 0, and then it's going to go out forever to the right, so to positive infinity. Right? And then remember, infinity always has the bracket with it. Okay, what about the range? What would the range for this be?
Could it be 0 to infinity, or is that even possible?
Yeah, it is, because range, we're looking from where to where?
From bottom to top.
Yeah, from bottom to top. So the very lowest point of our graph is at 0, and it includes it. And then again, remember, even though this is kind of going up slow, it's still going up and out forever. So it's still going to get to positive infinity, right?
Okay.
Further and further we go. Okay, so make sure you know how to find the domain and range for any kind of graph that you're given. All right, there will definitely be a question on the test about domain and range. So please, you know, make sure. And remember, it doesn't just, one thing that I noticed on one of the quizzes where we had domain and range, some people were saying like 0 to 9, because that's as far as it went on this grid. Well, that doesn't mean that's where it stops. It's still going out forever, right? That's what this arrow is saying. So make sure that you're seeing that, okay? All right, let's look at some things then with the square root. So when you're trying to find the square root, and probably I'll just kind of come down here and maybe do 49b. All right, so you're first going to break down, right, whatever number it is you're given. So I know 4 times 5 is 20, and then 4 breaks down to 2 and 2, right? I'm trying to get these to all prime factors. And then I've got 7 x's that are inside there, right? But there was kind of a shortcut way that we talked about being able to deal with those variables. But inside here, I'm going to put 2 times 5, and then x to the 7th power. Right? So when we have 2 of the same, it gets to come out. Right? So 2 gets to come out, but 5 is still stuck inside. Right? And now we need to look at our x's. How many x's get to come out, and how many have to stay inside? Right? Well, we said, remember that this is a square root, right? So there's kind of like this little invisible 2 here, right? That's telling us, right, that things have to come out in groups of 2. So we're thinking, how many groups of 2 are there in 7? Well, 2 divides into 7 3 times, so x to the 3rd gets to come out, and then there's still 1 left over in there. Right? And we also did the thing where, you know, if you want to just write out all of, you know, all of your x's, write out all 7 x's, and then you can see, okay, there's 1 group, there's 2 groups, there's 3 groups, right? So that's why 3 gets to come out, and then there's 1 x still left inside. So whatever, you know, makes better sense to your brain, or, you know, if you get really high numbers, though, you might not want to have to list them all out, but you could, okay, on that. Okay, let's keep going here. Let's talk about the square root property now. Remember, the square root property was, you know, if we have something written in this form where we have something all squared, then we could take the square root of both sides to solve it that way, right? Remember, we talked about, there's 4 ways that we've talked about solving quadratics. Right? So this is one of those 4 ways, the square root property. So let's do part C together. So on part C, right, to undo squaring the x minus 2 all squared, I'll take the square root of it. But then that means I need to take the square root of the other side of the equation as well. Right? Whatever I do to one side, I have to do to the other. All right, then that square root and that square, all right, cancel each other out. And so then I'm just left with x minus 2 on the left-hand side. And then on the right-hand side, right, I'm left with plus or minus the square root of negative 13. Okay, but what do I need to do with this square root of negative 13? How does that simplify? Anybody remember? You can type it in the chat box if you can't talk or something. I know some of you have a lot of things going on. It might be, you know, noisy or whatever. You can type things into the chat box. How would we simplify this? All right, well, when there's a negative inside the square root, all right, you've got to remember that whenever you see, like whenever there's a negative inside the square root, square root of negative 1 is I. Right? And then you also need to remember when we're dealing with imaginary numbers, right, that I squared equals negative 1. So these are 2 super important things to make sure that you keep in mind, right, and you remember here. So this is basically saying negative 1 times 13. I could write it like that inside there. So that means I is going to come out in front. Okay, so this side's staying the same. X minus 2 equals plus or minus, and I'm going to bring an I out. Now, if it was like, you know, negative 16, then that would simplify to be 4i. But right now, 13 is not a perfect square, so 13 still has to stay inside the square root. Right? And then to get x by itself, I just need to add the 2 over. So my answer would be x equals 2, right? Put your number in front, plus or minus I square root of 13. Okay, and you can write that I at the end of it, but I know some people on their homework were kind of having issues with that when you had to do the I, because sometimes you accidentally get that, you know, like it's reading it as though that I is inside the square root. So make sure, I mean, it just makes more sense to bring it out in front, then you can tell for sure it's not inside that square root. Okay, so that's the square root property. All right, if you have something all squared, take the square root of both sides and solve it. And remember, this is 2 different answers, right? 2 plus I squared root of 13, 2 minus I squared root of 13. And I'm expecting to get 2 answers because of that. My highest degree is a 2. Need that exponent there. All right, let's do one of these completing the square ones. Okay, I'll do the harder one. Let's do this one together, and then I'll save that other one for you to do on your own. And the reason why this one's a little bit harder is just because our leading coefficient isn't 1, it's 2. And so remember, we have to divide that out. We got to factor it out of our first 2 terms here, okay? But the first thing we want to do is let's get that constant term over to the other side. So let's subtract 5 over to the right-hand side. So that gives me 2x squared plus 8x equals negative 5. All right, now I want to rewrite these putting my blanks in. Or sorry, no, let's divide out the 2 first, okay? So if we factor a 2 out of both of those, that leaves me 2. And then in parentheses, x squared plus 4x, right? But then I'm going to go ahead and put my blanks in also. You could do it on this step, or you could do it on your next step. But just make sure you see that you have to divide that 2 out first, okay? Then that's going to equal negative 5. But whatever we did to one side of the equation, we have to do the same thing to the other side. Right? So I've got these blanks to fill in. All right, so how do I figure out what number goes in my first blank?
I can't remember, but is it 4 divided by 2?
So
Or 4 times 2?
Yep, so you do 4 divided by 2 first. 4 divided by 2 is 2, and then what do you do with that number?
2, is it the 2 times 2? And
Yeah,
then put
2 to the second power. Yep. So that's going to be 4. That's going to be in that first blank. All right. But what's going to go in my other blank?
8?
Yeah, how did you get 8?
2 times 4.
Yeah.
I did the...
Yep, that's exactly right. Right, we got it because it's not really 4 that you added to this side because we have this timesing by 2 there. So 2 times 4 is 8, so we need to add 8 to this side. All right, now let's simplify this, right? Because basically we're doing this complete the square because we want to get something to look like, you know, like maybe this part B up here, where we're going to be able to use this square root property. That's the whole reason why we do this completing the square when we're solving quadratics. So that 2 is going to stay on the outside. And then this x squared plus 4x plus 4 is going to factor to be x plus 2 all squared, right? Because that's going to be x plus 2 times x plus 2. You factor that. And then equals, and we've got positive 3 on the other side there. Okay. Now this one has a little bit, you know, next thing we have to do, we've got to get that exponent, or sorry, the squared part by itself, right? And so if you're trying to get that squared part by itself, then you need to divide everything by 2 first, right? So let's do that. So if we divide by 2, Right? Then I'm left with, come over here, and I'm going to be left with x plus 2 all squared equals 3/2. Right? And some people are like, oh, I hate these fractions, okay? But don't let it freak you out, right? Our next step, to get rid of that square, we're just square rooting both sides. Right? So that's going to give me just what's inside comes out, right? Because that square root and that square cancel out. I'm left with x plus 2 equals plus or minus the square root of 3/2. And then I just need to subtract my 2 over. So x equals -2 plus or minus the square root of 3/2. Right? Make sure if we have that whole fraction is inside the square root, make sure it looks that way on your answer, not that it just looks like the top numbers inside the square root, right? They both are there. Okay, so this other one, part A, will be easier to do, but I wanted to work through that one with you because it was a little bit more challenging, right? It had the leading coefficient was 2, and then we ended up kind of with a fraction there at the end, but really it's just still the same idea, so don't let those fractions freak you out. Okay? All right, let's look at this next one then, right, with the quadratic formula. So I'm going to write the quadratic formula up here just to remind us what it is. So x equals -b plus or minus square root of b squared minus 4ac all over 2a. Right? But you can look it up since you're going to have access to your notes, so make sure you have that written in your notes somewhere that you can refer to quickly. All right, and then remember that a, b, and c in this are found from our coefficients. So let's do this part A1 here together. So on this, our a is our leading coefficient, so a equals 1. Our b is 2, and c is 7. Right? And if everything wasn't over on one side, and the other side equal to 0, then you have to move everything over, right? We always have to do that with quadratics. Get everything over to one side, put the other side equal to 0 before we can attempt to assign what a, b, and c are. All right, and then let's just go ahead and put that into the equation there. So x equals -2 plus or minus square root of 2 squared minus 4 times 1 times 7. All over 2 times 1. Doesn't flow as well when you have to say the numbers, but whatever, right? Okay, so now let's just kind of simplify what we have here. So I've got -2 plus or minus, and let's see what we have inside my square root here now. So I've got 4 minus 28. Right? I've got to multiply all these guys together. Right, so I've got 4 minus 28, which is going to give me -24. Right, and then all over 2. Right, but now I need to simplify this. Right, so I've got a negative inside my square root. So that means I'm going to have to, it's going to have an I in my answer. So I'm going to first break these up so both things are being divided by 2. So I'm going to do that on this next step. So I'm going to have -2 over 2 plus or minus, now let's simplify that, negative square root of 24. Right? So if I take 24 and I break it down, that's 6 times 4. 6 times 4 is 3 times 2, and 4 is 2 times 2. All right, so a 2 gets to come out. And then since it's negative inside there, an I also gets to come out. All right, so 2i gets to come out. But then this 3 times 2 is what's left inside here. All right, so there's still a 6 that's left inside there. And then we're going to still, right, we're dividing both of these by 2. Okay, and the reason why it's easier if you split these up is because now you can simplify these easier, right? Negative 2 divided by 2 gives me negative 1. And then this 2 divided by 2 also gives me 1. Right, so you can see this. Right, so that's going to give me just I on the outside and square root of 6. Right, so that would be my answer there. And remember, if you come up with an I in these, remember what you're really finding here when you're solving these quadratics is you're finding the X-intercepts. Okay, so this finds, let's see, I'm just going to put it this way. So solving quadratics, right, finds the X-intercepts. Okay, but on this one, right, since we got an imaginary number, that means there are no X-intercepts in this function. All right, so I'm just going to put down it's imaginary, so no X-intercepts. Okay, it didn't ask for that specifically on this one, right? But it does ask that on some other ones, so I just want to make sure that you see, what we're really finding here and what it's telling us about that. Okay. All right, so let's probably do one of these on 53. I'm trying to think which one I want to do here. Is there any of those that you'd like me to work through more than the others? I mean, remember that, so it's asking you to find the vertex, the x-intercepts, the y-intercepts, and the axis of symmetry. Maybe I'll do a couple of them just because I want to help you see, what you can do here. So let's look at part A first. On this one, this is in standard form, but but if you try and, factor that, that would be the first thing that you'd want to try there, is see if you can get that factored. And so let me write that down underneath here. So this factors to be 5 times 2 is 10, and then they add to be 7. Oh, I didn't give myself enough space there. Okay. And remember, by factoring these, right, I'm finding my x-intercepts here first. Okay. So I'm factoring this and then setting it equal to 0. Right, so then when I set each of those parts equal to 0, I get x equals -2 for that one, and x equals -5. There, right? I set it equal to 0, and then bring it over, right? Let's subtract it over. So, and remember, if I was writing these as ordered pairs, right, that would be -2, 0, and -5, 0. Right, so these are my x-intercepts. Okay, so there's part of my answer, right? I did the x-intercept part. Okay, now let's do the y-intercept. To find the y-intercept, I let x equal 0 and solve for y. Right, so for the y-intercept, I'm going to solve for y, so I'm going to have y equals 0 squared, right? I'm putting 0 in place of my x, plus 7 times 0, plus 10. And then when I combine those all together, I get y equals 10. But again, as an ordered pair, right, that would be the point 0, 10, because we put 0 in place of our x's and found our y to be 10. All right, so there's another answer. All right, got my x-intercepts, my y-intercept, right? And my axis of symmetry, remember, is going to be found from my vertex, so it would be best to find my vertex first here, okay? And this is all still part of A, so just to kind of go like this, we remember that it's not, I'm not doing B underneath here, this is all part of A, right? But remember, when it's in standard form, and I'm trying to find the vertex, you're going to use that vertex formula, right, which says x equals negative b over 2a. Right, that's how we find our x value. And so on here, that's negative 7 on the top, and then 2 times 1 on the bottom. So that's just 2. Right, so it's negative 7/2 is part of my vertex. Remember, my vertex is going to be an ordered pair. Right, so negative 7/2 is my x. Then to find my y, I need to plug that negative 7/2 into the equation that's given. Right, and this one's kind of crazy because we got some fractions here, right, but we can do this. So I'm going to say negative 7/2 all squared. Right, and you can use your calculator to help you out with this too. Or if you even wanted to put that in as negative 3.5. Maybe I'll just do it that way because I bet that's how most people will want to do it. So let me change this. So remember that if you do negative 7 divided by 2, that's going to give you negative 3.5. Okay, and I'm fine with you changing it to a decimal if that makes better sense to you. So let's put that in to our equation then. All right, so I've got 2. Oh, whoops, sorry, I'm looking at the wrong equation. Looked at B when I wanted to look up here at A. All right, so let's put in negative 3.5 squared plus 7 times negative 3.5 plus 10. All right, and most of your calculators, you can just put that whole thing in there and see what you come out with. Right. Okay, and I think it's negative 2.25. Don't know if anybody else tried that. Is that what you got?
Did you say negative 2.25?
Yeah. Is that what you got?
Yeah.
Okay. All right, so then that's my vertex, right? So I found another part of what I need here. And then the last thing that I needed to find is my axis of symmetry. But remember, my axis of symmetry is just the line that goes through my vertex, that vertical line that goes through there. So the axis of symmetry is just going to be x equals negative 3.5, right? It's that line, x equals negative 3.5. All right, and then we want to make sure that you know how to graph it too, using these 4 things now. So let's just kind of make a little rough sketch of what this might look like here. All right, so let's see, I'm going to start with my vertex, so negative 3, so to the left 3.5 and down 2.25, right? And this is just going to be kind of a rough sketch. I'm just kind of guessing, you know, where these are at. And then my x-intercepts are at negative 2. Actually, let me do this in a different color. It's just easier to see. So negative 2, 0, and negative 5, 0. Right. And then my y-intercept, well, I need to go up higher here. All right, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be there. And then my axis of symmetry, right, is going to go through here. And that just helps me to see, oh, well, I'd have another point over here, right? Because every point on one side of the parabola is going to match up with another point on the other side. So that axis of symmetry can help us find more points if needed to kind of help us draw that graph out. Okay, so this is all part A here on the top. Okay, is there anything on that that you wanted to ask about? Okay, let's do one more. Let's do part F also. Okay. So we can kind of get an idea here of what we need to do. So this is in vertex form, right? So it's easy for us to pick out what the vertex is when it's in this form. Okay, so all the stuff that I'm doing here on this lower level is just going to be part F. Okay, so the vertex, right? Insiders or liars, so 4, comma, positive 2. If it's on the outside, it just stays the same. Okay, so vertex, we got that, right? And like I said, that's what's nice about this form is you can easily figure out where that vertex is at, right? Which means we can also find that axis of symmetry, right? So the axis of symmetry, remember, it's always going to be that x of our vertex. So it's the line x equals 4. Okay? And that's a vertical line at 4. Okay? So there's two things we've already found. All right, now we need to find the y-intercept and the x-intercept. Okay, so let's find the y-intercept first. So to find the y-intercept, let's see. All right, we're going to let x equal 0. So I'm going to have negative 2 times 0 minus 4 all squared plus 2. All right, now I just need to use order of operations to kind of simplify this. So negative 4 squared is 16. So I have negative 2 times 16. All right. And then I have plus 2 there. So y equals negative 32 plus 2. So y equals 30. All right, so as an ordered pair, right, that's 0, 30. Okay, so there's one more thing I need to know. Okay, now let's do the x-intercepts. All right, to do the x-intercepts, right, we're going to let y equal 0 and solve for x. And so on this, we're going to use that square root property, right, because it's already set up in this vertex form. And so we will be able to kind of square root both sides here. So we want to use that square root property. Okay, so I'm going to say y. So I've got
I have a question.
Yeah.
That y equals 30, should it be negative 30?
It should be. Thank you.
Okay.
Yes.
I didn't want you to get further and be like, what?
I know. Wait a minute. No, I'm so glad you said that. It definitely should be. Awesome. Thank you. So we'll have x, so 0 equals negative 2 times x minus 4 all squared plus 2. All right. So remember, when we're trying to solve this, the first thing we need to do is get that squared part by itself. So I'm going to start by subtracting my 2 over to the other side of the equation. So I've got negative 2 equals negative 2 times x minus 4 all squared. And my squared part is still not by itself, right? I need to divide both sides by negative 2. All right, so when I do that, those divide out, and this divides to be 1. All right, so I get 1 equals x minus 4 all squared. Okay, and now it's to that point, right, like we had up here in those square root properties, right? It looks like this now, so now we can square root both sides to try and figure out what x is. So let's square root this side, and that will get rid of our square root and our square, and square root this side. Right, so remember when we take the square root of that side, it's not just the square root of 1, it's plus or minus the square root of 1. Right, and then, oops, let's see, actually let me write this in, just gets a little bit hard to see. Let's do, so plus or minus 1, square root of 1 is just 1, right? So, and then we're going to have x minus 4 over here. And then to get x by itself, we need to add the 4 over. Okay, so I know this looks kind of weird here, but what we really have, right, is 4 plus or minus 1 equals x. Okay, but let's think about what this is really saying. All right, it's saying 4 plus 1 equals x, but then it's also saying 4 minus 1 equals x. So we get x equals 5, right, and x equals 3. All right, so our x-intercepts, we write those as ordered pairs. We'd have 3, 0, and 5, 0. And now I have all of those 4 things, and so now I can graph those, right, to what I have here. And since this is, it has a negative out in front there, just kind of point to this, right? So this negative means it's going to be an upside down parabola. Right? So let me just kind of write that down here. Okay, so that's going to be an upside down parabola. And so we can already see that. And that's just kind of a little check for us to be able to try and, you know, just double check when we're graphing these, right? So. All right, I'm not going to go all the way down there, but so if we have our vertex, so over 4 up to, it's right there. Oops, I thought I had it in pink. All right, and then I've got, so that's my vertex, that's my turnaround point, so I know it's going to be an upside down parabola like this. All right, my x-intercepts, here is 3, 0, and here's 5, 0. Right, so that's looking good so far, this upside down parabola. And then I know my axis of symmetry, right, is going through right here. Whoa, that looks, got off course there, but okay, there's my axis of symmetry. And then I'm not going to, you know, get this all the way down here, but let's just say, okay, here's, you know, negative 30 is at some point down here, right? And so then we're just going to make sure, right? And if it goes off, you know, the graph, you know, for, you know, what you're working with on, I mean, most of them should stay on the grid that's given, but if it goes off a little bit like that, that's fine. You can just kind of make a little rough sketch of what that might look like. Okay, so remember, we're using all of those things to figure out what does this graph look like. Right? Okay, what questions do you have on that one? I know we're kind of a little bit over time here, but I do want to do one more problem, one of those story problems, and then I wanted to check and see if you had questions about the Pythagorean theorem, with the circles, or anything more with imaginary numbers. We dealt with a little bit of them in here, but I wanted to see if there was any more specifics on that, because those are kind of some things that I added in, remember, that weren't part of the book that you need to know on this. All right, let's do number 55. And actually, I mean, you could do 54, you know, on your own. I don't worry about doing 56 or 57. I'm not going to put anything like those on the test. Okay, so maybe write that down somewhere. The story problems that you might be dealing with will be more like 54 or 55. Okay, so we'll just kind of focus on these on here. All right, so let's look at 55. So first of all, it says Bob owns a watch repair shop. He found that the cost of operating his shop is given by that function. Okay, C of X is the dollars, right? The cost in dollars, and X is the number of watches repaired. So first of all, right, it wants us to write an equation, or sorry, that's in the complete the square form, or that vertex form. All right, that's what we're going to do there. I think if I put these in. Sorry, just looking at something else here. All right, let's look at this. So to change this to complete the square form, right? Remember that we need that leading coefficient to not be 4. We've got to factor that part out. All right, so let's rewrite this. So we've got y equals 4x squared. Actually, I think it's just easier for most people to have it on the other side, so let me rewrite it this way. So 4x squared minus 288x plus 59 equals 0. Well, actually, yeah, we want to write it in vertex form. I'm sorry. Let's do it the other way. All right. Y equals 4x squared minus 288x, and then plus 59. All right, but remember, we're going to take those first two terms and factor the greatest common, or the leading coefficient out of it. So that means 4, all right, needs to be factored out, and that will leave us with x squared minus, well, let's see, what's 288 divided by 4? 72. And then we can also put our blanks in, right, at this point. So plus blank, right, because I'm trying to make this into a perfect square trinomial, right? And then I still have that plus 59. And everything is on the same side of the equal sign. So remember, on this one, I need a minus blank, right? I'm adding a number to this side of the equation, so I have to subtract off that same number to keep it balanced. All right, so let's figure out what this will go in this first blank. So we're doing negative 72 divided by 2. All right, that's going to be 36. All right, and I'm not going to give you this big of numbers on the test. These are kind of crazy. All right, so 36, and then we got to square 36. It's going to give us 1,296. All right, but remember, that's not what's going to go over here because we have 4 times that. All right, we need to do 4 times that. So that'll give us 5,100, whoops, 5,184. Goes in that other blank. Okay, and then if we get things kind of simplified up here, right, so y equals, still have that 4 on the outside. My perfect square trinomial is going to be x minus 36. Should have had a minus there, but okay, minus 36. And then squared, and now I just need to combine these guys together, right, to get my last term over there. Oops. Right, so then if I minus off 59, let's see, that gives me negative 5,125. Right. Okay, so now it's in this vertex form. Now we're going to kind of try and make sense of what this is talking about, right? So this is a right side up parabola because that leading coefficient's positive. So I know it's going to be going upwards like this. So that means that the vertex of this is going to be a minimum. Okay. Oops, let's see, minimum. Easy for me to spell. Okay. And so that vertex is a really important part of this. So I'm going to actually write that down here, what our vertex is now, right? So our vertex is going to be 36, right? What's inside there? Insiders or liars, so make that positive. And then negative 5,125. That one stays the same over there. Okay. All right. So I'm saying, how many watches must he repair to have the lowest cost? Right. Well, X is the number of watches repaired, right? And that is 36, right? And then it's kind of weird that this ends up being negative there, right? But when we're talking about, you know, the lowest cost, right? Doing this, let's see. Sure. All right, so he must repair 36 watches. And then the lowest cost, right? If he repairs 36 watches, then it looks like he's going to save $5,000 in his overall expenses. Right. So it's kind of weird that it's negative there, but that's kind of the idea to this, right? So again, just make sure that, you know, on these story problems, you're thinking about, you know, like, are we dealing with a maximum or minimum, right? And that's going to come from our parabola, the vertex of our parabola. And so that kind of tells us a lot there about it. Okay. All right, what questions do you have on, is there anything that, I don't know if you've had a chance to kind of look at some of the stuff, or if you remember from yesterday, if you had some questions on the circles, right, or Pythagorean theorem, or anything more with imaginary numbers. Is there anything on that you'd like to cover here too today? And some of you may not have had a chance yet to do some of, you know, those worksheets and stuff. So feel free to reach out to me, though, when you know, are working on them, and if you have any questions. And, you know, we could, you know, I can definitely help you some more this weekend or something, too.
Could I ask you a question about quiz 10?
Yeah.
So on number 3,
Let me pull it up. Let me pull it up really quick so I can.
A little bit wonky, and I don't know if I'm doing something wrong.
Okay. Let me see here. Whoops. Ugh. Hold on a second. Do you want to just tell me what it said, and we can just work it out over here to the side? I thought I had it, but I don't.
Okay, so it's 3 times x minus 1 squared
Okay.
minus 5.
Okay, and does it say like?
It's f of x equals,
F of x.
and then it says to find the x-intercepts, the y-intercept, the vertex, and then graph it.
Okay. So yeah, so it should be kind of like we did up here, right?
And so I found the x-intercepts doing it like we did up there,
Mhm.
with just the vertex equation and square rooting. And then I also did it with the quadratic equation.
Mm-hmm.
And I got different square root numbers, but if I put them in my calculator, they're the same decimal.
Okay. So it
So
could just be that those simplified differently. So sometimes, you know, like, I mean, the look of them, but if you're getting the same decimal answer, then that means it is correct. So to do this, the way that, like, if you use the quadratic formula, you had to FOIL this out, right? And then, distribute the 3 through, and then make sure that you include that 5 there, right, to get all of that. But yeah, so it sounds like, I mean, so there are different decimals, or different, sometimes the radicals might look a little different. Like, so if I had 3, like this, the square root of 3/4, I mean, I would accept that as your answer. You know, I wouldn't mark anything off for that, but we could also say that's the square root of 3 over the square root of 4, which is really square root of 3 over 2.
Okay.
Right? And so sometimes they can look different. So if you had this, that's correct. If you had this, that's correct. So, so that might be all the issue is there, is that it might look different, but it's still the same. If it's, as long as it's the same decimal, it's the same.
So I've got like the square root of 15 divided by 3. And then I got the square root of 5 over 3 all in the square root.
So the square root of 15 is the 3 inside the square root on this one?
The 3 is outside.
Okay. And then what did you say the other one is?
I'm sorry?
What was the other one?
It's the square root of 5 over 3. So all in the square root.
Okay. Yeah, so square root of 5 over 3. Yeah, and those are the same, actually. So
I was having a hard time wrapping my brain around how they would be the same, but
yeah, and they are the same. So, I mean, there's something that you're going to talk about in your next class that's called rationalizing a denominator. So like how I, you know, broke these up and I said, okay, that's really the square root of 5 over the square root of 3.
Right.
Well, we don't like to have square roots on the bottom, but if I multiplied this by another square root of 3, the square root of 3 times the square root of 3 is just that 3, and then the square root of 5 times the square root of 3 gives that square root of 15. So those are totally the same numbers.
That makes sense. Okay.
Okay, yeah. So on a lot of those, I mean, I definitely, on the test, it does ask you to do, you know, the exact answer and the decimal approximation. And yeah, feel free to, you know, if you're like, I'm not sure if I did this one right, you could check it with a different method. But yeah, just make sure that you're using the method that I asked for there and that work is shown on it. But you can do, you know, other work over to the side just to check. Because like I said, I mean, there's no time limit on this, right? And so you could, you know, take your time and just kind of make sure that you got these, you know, figured out. But yeah, thanks for asking that, because that's a really good thing to like know that, okay, even though those look different, they are the same thing in the end.
Right. Now it makes sense that you explained it that way, because I was not getting how they would possibly be the same, but they were in my calculator, so I figured I did it right.
Yeah. Yeah, so you'll talk more about that in 1050 next year, about that, rationalizing those denominators. Okay. All right. Is there anything else you guys wanted to discuss? And Nick, if you can stay on, I wanted to talk to you after we're done here. But did you have a question too, Nick?
No.
Okay, you just unmuted yourself. So I'm not sure.
All right. Bye. Thank you.
Okay, bye. All right, Caitlin, Monica, you guys good?
Yeah, I'm good. Thank you.